We're going to first download a template file that we'll use to save our SQL code. It's just a raw text file. Make sure to replace your first name and last name in the file name. And then if you're on a Mac and using Chrome, select all files formats so it doesn't add this txt extension, and you can just delete it out. So make sure that the file ends in .sql. Then go to Table Plus, connect to your sales orders database, and then open up the file we just downloaded. The assignment 3 details will be available to you by tomorrow night or Saturday morning at the latest. So look out for that. And again, this is a paired activity, so you can help each other out on this assignment, but there will be no presentation portion. All right, so for this lecture, we'll cover variables. So that way we don't have to hard code everything into our SQL code. We can use variables, which then can be used as containers for different information. And then we're going to also look at prepared statements as a way to secure our SQL queries and also to make them run more efficiently. I know most of you have already taken a programming class. We're going to spend some time doing a little refresher on variables. So variables, as you already know, they're just something that holds information for us because that value will change or can change over time. And then you're going to reference those variables for a later purpose in some way. And we want to use these variables in a way where the data that they're representing is clearly labeled. So that will be in the variable name. So when you name variables, we have to make sure that the name represents what's inside that variable. And we're going to spend some time on best practices for variable naming conventions. And those variables will then last in memory until the program stops executing. So why would we need variables in SQL? You might think we're just writing code and then we're done with it. We're slowly building up to stored procedures, which are programs that you can run on a SQL database. So you want to use a variable because you want to pass some sort of value between multiple SQL statements. A few tips on how to name variables. Okay, only use abbreviations that are widely known. It's tempting to use abbreviations to save on typing, but if it's only known to a small portion of people, you can run into problems because people may misinterpret those variables. Even if it takes more keystrokes, it's worth having clarity over brevity. So don't try to abbreviate or use shorthand if it's going to cause any sort of confusion. But in the end, follow whatever the rest of the team is doing or what the rest of the project has followed as a standard. You don't want to start introducing different naming conventions or different formats because it can make things a lot more confusing when you're trying to debug. And please avoid single character variable names. Now, we've seen so many examples in Python. When you do a for loop, it's something like for I in, or you're in a rush and you're trying to quickly debug, so you use single character variable names, but don't do that because if you forget to replace it out, you might forget what is this variable representing. So how do we name lists or arrays? Well, these types of variables are related to when you run a SQL query and it comes back with multiple results and not just a single row. Kind of like how we make considerations about how we name tables, same thing goes for naming lists and arrays. You want to use a plural version of a name because it'll tell the user, well, there are multiple items, or there's the possibility to have multiple items in this variable. So when you're naming lists or arrays, use the plural form. The first example shows a list variable called animal. There are 3 items in that list: dog, cat, and snake. But animal, it might just mean, okay, maybe there's only 1 item in that variable. So a better one would be if we use the plural version of it, animals. But then even better than that is if you added animal names, because it tells the user, well, what's inside of this list? It's plural, and what's in here are the names or some sort of string in these lists. How do we name booleans? Well, what are booleans first? They are types of variables that can have 1 or 2 possible values. Okay, it's an either or value. They can be true or false, a 1 or 0, active, inactive, but a boolean means it can only be between 2 sets of values. Well, when we name boolean variables, we want to add some sort of prefix to give us an idea of what this boolean means. So here's one bad example. Okay, what does an open variable mean? Okay, it has some ambiguity around it. Or right equals true, fruit equals true. We don't know, well, is it a fruit, or can we write to it, or is it open? It's not sure because we don't have some sort of prefix to better define this boolean. To make it a little bit more clear, you could say is open. So if it's a true value, you know that it is open. If it's a false value, it's not open. Or can write, can this file be written? Or can this object be written? If it's set to true, then that means that you can write to it. If it's false, you cannot. And then has fruit. Does whatever you're trying to describe have fruit? If it's set to true, then it does. Okay, so adding these prefixes makes it a lot more clear what this boolean is trying to say about the value. When we name numbers for variables, we want to add something that describes what does this number represent. Okay, so if it's some sort of aggregate function, or it was set because of an aggregate function, we want to know about that. So a bad example is saying clicks. Most of you would think, okay, well, it's just probably the total clicks or the number of clicks. But some people may interpret it differently. So a better way of saying is, okay, we'll describe it. Is it the minimum number of clicks? Is it the maximum number of clicks? Or is it the total clicks? So instead of clicks, okay, your first instinct is probably total clicks, but it's better to add a prefix to say total clicks or something like some clicks. When we name procedures or functions, okay, so a procedures function is a set of code that does something. Okay. You want to use a verb and a noun so that we could describe an action and what that action is, what the object of that action is. So it's describing some sort of action performed on a resource. So if the function name was user data, it doesn't tell you what it's doing to the user data. Okay, so you pass in a user ID argument, a user ID variable, but what is going to happen with that user ID? We don't know. We know it's something about user data, but what specifically, we don't know. Same thing for a total sales function. It doesn't tell you what it's going to do. But if we added a prefix or some sort of suffix like get user, okay, we pass in a user ID, then we know we're going to get details about this user. Maybe their first name, last name, something that describes the user. Or if we're going to calculate sales, we could see, okay, is passing in the product ID will give us what is the total sales count or the total sales revenue. With total sales, we don't know, is it the number of sales lost, the total number of sales gained. But by adding some sort of verb, we know what is happening to the data. Okay, so always use a verb and a noun when you're naming procedures or functions. So all of these recommendations apply not just to SQL, but to all programming. There are two types of variables in MySQL. There are user-defined variables, which we're going to cover today, and then there are also declared variables that you'll find in the programs that we're going to write, specifically stored procedures. Declared variables we'll cover in another lecture. User-defined variables, they always are prefixed with an @ symbol. So it'll be written in this format, @ symbol and then the variable name. So the variable name can have alphanumeric characters, okay, including periods, underscores, and $signs, but I would avoid the $signs. And you can use camel case, underscores, lowercase. And these variables, they only last for that session. So when you log into, let's say, Table Plus or any sort of SQL client, when you define this variable, it will go away once you close the client. So the variables that you name during that session, they can't be seen by another client. So if there are two people logged into the same database, they can't see each other's user-defined variables. And these variables are case insensitive. So you can have varying capitalization, but if the same number of characters are used, or the same characters are used, it doesn't matter. So @ orders is the same as capital O orders. A couple of ways of setting these user-defined variables. Okay. So the first method is with the set keyword. So you say set, the variable name, and then the value. Or you could use the select method with a similar format. So there you could use set or select. But with the set method, there are two ways to assign the values. You could use the equal sign, but you have to be careful because if you use the equal sign outside of a set, it's going to check, okay, is this variable equal to this value? It's not going to set it to that value, which you may normally assume because that's how you assign variables in other programming languages. So the preferred way is using this := operator. This will minimize the confusion, and when you see it, you know that, okay, a variable is being set here. So the preferred way would be this first method with a set, and then the variable name, : equals, and then the value. All right, so for our first example, we're going to find the most expensive product, and we're going to use the set variable method to store that maximum value to a variable. And then we're going to pass that variable to another SQL statement. Passing that variable to another SQL statement because it will be part of the where condition. We're going to say find the products where its retail price is equal to this maximum retail price that's stored in this variable. All right, go to your Table Plus and you should have the template SQL file open. So the first thing we're going to do is figure out what is the maximum retail price out of all of the products. We'll just run a basic query here. So we're going to use the aggregate function max on the retail price column. $1,800 is the maximum retail price. We're going to take that value and then set it to a variable. We'll just type it out. We'll type out the $1,800 value. And we'll use camel case for these variables. I know the column names and the table names are not following camel case in the database, but we'll use this for now. Okay, so camel case is where the first letter is lowercase and then the first letter of subsequent words are capitalized. So this is the format that looks closest to what the database is following. Say max retail price. We're trying to describe this variable, what it is. It's the maximum. We know it's $1,800 because of our previous query. So if you run that, and nothing comes back aside saying 0 rows affected as long as you don't get an error. But at this point, you've defined a user-defined variable. So this variable will last for this session. When I create a brand new login to the sales order database, if I try to find out what's inside this max retail price variable, it will be empty. So how do we know what's inside this variable? We can simply do a select on the variable name, and it will return what's inside that variable. We're going to then use this max retail price variable to figure out what is the product or products that have this maximum retail price. Select star from products where retail price equals this value assigned in the variable. So all it's saying here, where retail price equals $1,800. And then you can confirm because in the retail price it shows $1,800 and there's only one product that has this maximum retail price, the Eagle FS3 mountain bike. To do the same thing, we're going to find the maximum retail price for what is the most expensive product in our database at this time. But instead of using the set method, we'll use the select method. And we'd want to do this because let's say we add a new product into the database that has a retail price greater than $1,800. So let's say it's $2,000. If we were writing all of this code in some sort of file in a script that we pass on to somebody else, it will no longer hold true if we add that new product that costs $2,000. So we can dynamically get the maximum retail price by using the select variable method. So we're not going to do set at variable value because this also adds an extra step, but if the value changes, it will throw off the rest of the script. So we're going to use this method instead. Select into this variable name the value from a table. Okay, so we will use the select method. So we'll directly assign the variable here in the select statement when we get the max retail price. We'll use the same variable name, max retail price. We'll use a colon equals operator to assign the variable, and then the rest of it is the same. Max retail price from products. We're still getting the maximum retail price in this query, but it's automatically assigning it to this variable at max retail price, this user-defined variable. If I run this, okay, it's assigned the variable, and then you can double check again, but it should still be $1,800. Okay. So now that we have the maximum retail price in a variable, we can run the same query to figure out which products has this maximum retail price. Again, it's the Eagle FS3 mountain bike. Okay, what if we didn't have variables? Just as a good exercise, we're going to find the most expensive product with a subquery and no variables. So see if you can write a subquery to get the product or to get that Eagle FS3 mountain bike using subqueries. Okay, so you're going to select from the products table based on a retail price that has the maximum value for all of the products. Okay, so find the most expensive product with a subquery, but don't use any variables. We'll write the subquery first, which is just getting the select on the maximum retail price. We always have to enclose subqueries in parentheses. So I'll take out this semicolon, indent here. So then we need to get all of the product information based on this maximum retail price. So what do you think is the where condition here? Well, we're looking for products with a retail price that matches this maximum retail price, where retail price equals the value of this subquery result. I'll just keep it like this. We get the same result here. So what happens if you run a select query, but there are multiple values in the results? Because right now we've been running queries, but there's only one row in the result set. Well, if you assign a variable with a query that has multiple rows, it's going to just use the last row's value. Okay, so see what happens when you try to select retail price into a variable for all the products. The query would look something like this. So let's call it retail price as a variable, and we know there are multiple products, so let's just confirm what happens here. Run the query, there are multiple rows, but the variable can only hold one value. Verify by running a select on the variable. So we get the last value, $180. Again, if I run this query, if I scroll all the way down, $180 is the last row in the value in the result set. We're talking about variables because we're saying we're going to use these variables for SQL statements we're going to run later on. Well, some of the SQL statements we're running is going to insert into a table. And then we need to pull out the ID of that newly inserted item. So there's a function for that. It's called the last insert ID function. And this is specific to MySQL, but other databases have their own function, but they do provide this functionality. So it only applies to columns that have an auto increment value set to it. So we'll get the most recent ID generated by an auto increment column. So you insert into that table and you want to know what that most recent ID is, just calling this function will give you that ID. So it's very handy when you're writing programs in SQL and you need to pull that value out and then pass it to another SQL statement. So a common case is you get that recently inserted ID and then you're inserting it into another table to set it as a foreign key. So think about when you insert a new product, you need to get that new product ID, but if you want to associate a vendor to that product, you have to figure out, okay, what's that product ID? And then now I can insert it into the product vendors table. Okay, so we're going to create a new category, and then we're going to get that new category ID with the last insert ID function. But in the sales orders database, these primary keys, they're not set to auto increment because it was assuming you're not going to insert new rows. So we have to first modify the categories table such that the category ID is an auto increment column. So to run that, you run alter table categories, and then you're modifying a column. The column type stays the same. It's still an integer with up to 11 in length, but we're adding the auto increment attribute. Because in the end, we want to insert a child seats category into the categories table. So let's modify the table. Actually, let me just show you that it is not set to an auto increment. You could use the describe command on the table. All right, so empty doesn't show that it is an auto increment. So we're going to alter this table. Alter table categories, modify the category ID, because this is the ID that's going to come back to us when we call the last insert ID function. Still keep it to an integer, 11. Has to be not null because it's a primary key, and then set it to auto increment. So it affects all the rows that are in the categories table. Let's just double check again. It's been updated. Now it shows auto increment in this extra column. So go ahead and insert a new category where the description is child seats. You don't have to set the ID, the category ID, because that's an auto increment column. So you only need to set the category description column and set that to child seats. So go ahead and insert into the categories table. To do insert into categories, set category description equals child seats. It's inserted now, but let's say we need to get that category ID for the child seats and use it for another SQL query. And we don't want to have to run a specific SQL statement. We just want to call this select last insert ID function. Okay. So it shows 8. It might be different for you because I've been inserting into this table. So we could just double check by, let's just select all from the categories. So MySQL keeps track of the IDs used. If you delete from the table, it's not going to reuse the ID of that deleted column or of that deleted row. It's just going to continue auto incrementing. If you ever need to reset the auto increment, that is possible too, but just be careful when you do that because you can start running into duplicate key errors. Okay, so when I inserted into the categories table, it gave me back the category ID as equal to 8. When dealing with relational databases, adding one row into a table can mean that we have to insert data related to that new row into multiple tables. So let's say we're adding a new product to our sales orders database. So So we're going to insert a new bike product for a specific vendor. Okay. So we're going to add a new bike for the Big Sky Mountain Bikes vendor. But it's not simply just adding it to the products table. There are multiple steps that we have to do. So if you're building a web app or some sort of application that manages a relational database, you're probably going to add new products multiple times. So it behooves you to have some sort of script or application to do this, so you're not writing the code every single time. But if you're doing this, you don't know these new IDs that are coming out from these inserts. Okay, so we're going to insert into multiple tables to add this new bike product into the system. And we're going to use the last insert ID, and then we're also going to heavily use user-defined variables. So you can imagine that we're going to add this to, let's say, one script, and this script will be the new product script. Similar to what we just did with the categories table, because we're adding into the products table and we need to get its new product ID, we have to ensure that the product ID is, or actually here it's called the product number, is also set to an auto increment. So go ahead and go through that process of altering the products table so that way the product number is an auto increment value, and then we can run last insert ID whenever we run an insert into the products table. Okay, so here are the instructions, and go ahead and do this first before we start adding into the different tables for our new product. I'm going to verify the products table to see if its primary key, the product number, is set to auto increment. It's not, so we're going to alter the table again. Setting product number to auto increment. Looks like there are 40 products in our table. Double check. Okay, now it's set, product number is set to auto increment. We're going to insert into the products table. We have the columns here, or another way of figuring out what we need to insert into is it's helpful if you do a sample, run a select to get a sample of the rows to get an idea of what are the columns and what are those column values? What do they look like? So I'm just going to select 10 of the products to give us an idea of what to insert into the products table. All right, so we need to set the product name, the retail price, and the quantity on hand, as well as the category ID. So we got our 10 rows from the products table. And we're going to assign the product name, retail price, and quantity on hand to some arbitrary values, but we're going to set those as variable names. And then when we insert into the products table, what we set the columns to will be equal to those variables that we defined. Okay, so I'm going to set these variable names with the set method using camel case. So we need a product name, and I'll just call this Canyon mountain bike. And we also need to set the retail price. Again, use the colon equals. You could use the equal sign, but it just becomes more clear that you are assigning a variable when you do colon equals. And I'll set this to $823.16. And let's say the quantity on hand on our initial delivery is 96. So you can run all of these at once. So let me just double check that it did set it. Okay, good. If you get empty values, then run them individually, but it should work if you select them all and then run them all at once. Okay, now that I've confirmed those variables are set, we also have to get the category ID. But we're not going to hard set it. We know this is a bike, and there is a bikes category that exists already. So we're going to dynamically get the category ID and assign it to a category ID variable. So we're going to use the select method, kind of like what we did when we did the select for the max retail price and assigning it to a variable. We'll do the same here, but to get the category ID for the bikes category. So we'll assign it to category ID. From the categories table, and we know there is a category for bikes. So I'll just double check here. Yes. Yes. Or category description equals bikes. So I run it, it assigns category ID 2 to this variable at category ID. And I can double check with a select statement. Okay, good, it's set to 2. Now we have all of our variables set. We can go ahead and insert into the products table. We'll insert into the products table here using those variables we set. So we set the product name using the variable and not the string. And because we're using a variable, we don't have to worry about quotes. Okay, we don't have to put quotes around at product name. Okay, so we set the retail price to the retail price variable, and then the quantity on hand column to the quantity on hand variable. And we're going to set the category ID to the variable we set using a select statement. Let's double check our work. Looks like we got all the columns. We don't need to set the product number because it's an auto increment, but we'll get that value later on. Okay, no errors, says one row affected. We can double check our work directly here. We're going to select from the products table based on that product name. Okay, great. We have our Canyon bike inserted into the products table. The product number is 42, but instead of selecting for it based on the product name, we can use the select last insert ID function. So if we just run select last insert ID, it'll print out the last inserted ID of any table, of the most recent table inserted into. It's 42. We want to assign this value to a variable because now that we have the product inserted, we have to associate it to a vendor. Okay, so it's the Big Sky Mountain Bikes vendor. We're going to insert this product ID and the vendor ID of this vendor into the product vendors table. So you make sure you use the select and not set to assign the last insert ID function's result to a variable. And we do that because if you use set, it's not going to run the last insert ID function. We'll call this last inserted product number. And again, using colon equals and then running the last insert ID function. And that's why we use the select, so it will execute that function. Go ahead and run it, and then confirm the variable is set. Okay, good. So it's showing 42. Now that we have the new product number, we can insert into the product vendors table. We're going to get the product or the vendor ID by doing the same thing we did to get the category ID. We're going to set the vendor ID variable with a select statement. We'll call the variable vendor ID. And we're looking for a specific vendor name. Okay, so the vendor name is Big Sky Mountain Bikes. Okay, the vendor ID associated to them is 6. And we're just going to double check it was set. Good. Okay, so we already assigned the product number using the last insert ID. We got the vendor ID with that last select statement. Now we're going to use the set method to set arbitrary values for wholesale price and days to deliver. We're going to set the wholesale price. Say it's $605.80. And the days to deliver, so this would be the lead time. Set it to 11 days. Run, set that, the wholesale price variable, and then set the days to deliver variable. Kids select to confirm. I'm going to select them all at once on a single line. Okay, good. That looks good. Now, these select statements to confirm the values, you wouldn't have to do that if it's a program that runs within an application, or you could run it and then maybe output it to a file for debugging purposes, but I'm only doing these selects just to confirm that it's working and just for debugging. But you can leave them in there to print them out. So if you're running the script and you want to see it in action and you want to see where it is in the script, these select statements would be helpful. We have all our variables in place to insert into the product vendors table. So I'm going to just double check with a small sample select from the product vendors. Okay, we have the product number, have the vendor ID, wholesale price, and days to deliver. Okay, good. Now we can insert into the product vendors table. So the product number is the last insert ID, the last insert product number. Vendor ID, which we got with the select statement. Wholesale price we set manually. Days to, here I'll put this on a new line so it's easier to see. Days to deliver, again, was set by, with the set method. Let's see, anything else? I think that's it. Okay, good. So let's just double check it was inserted. We're going to query based on the product number. There you go. We see all of our values that we set. Now we can't, if we ran last insert ID, it will still show the product number because the product vendors table doesn't have an auto increment column that would generate a last insert ID value. Now that we know how to use variables and the last insert ID function, we can move on to prepared statements, because prepared statements makes use of variables and possibly the last insert ID. We want to use prepared statements for statements that we run repeatedly or that run within an application. So if you're developing a web app and you're writing some SQL, you'll want to use prepared statements. And we mainly do this for security reasons and for performance. So prepared statements run a lot faster just because of how they work with the memory of the SQL database. So definitely improves query execution times, selects, updates, deletes, inserts, because it caches a sort of a template for the SQL statement. The SQL database, it doesn't have to parse the statement and figure out what to do. It already has some sort of cached version of it. Because when we're inserting a lot of data into a database, these high volume inserts, they usually have the same format. They're referencing the same table, the same SQL structure, but all that's changing are the values that we're using in different parts of the SQL query. So values that would change are things like the conditions in a where clause, okay, or in when you're doing a select or a delete, or if you're running an update, what you're setting the column to, that's going to change, but everything else in the statement stays the same. Okay, the table, the columns that you're setting, but it's just the values that are going to change. And then when you do an insert, it's only those values that you're inserting, but the general structure of that insert statement is still the same. So that part improves the performance of a SQL query by using prepared statements. You can also use prepared statements to secure it against SQL injections. You maybe heard of this in maybe some news articles where some hackers maliciously typed in SQL queries into a form to insert SQL and then do something destructive to that database. Because in SQL, you can chain multiple statements together. So if I did something like, say, select count from, actually, I'll put this all in the same line so you could see what it means to chain them together. So I count from products and then say select hello, then maybe select, um, let's say days to deliver from product vendors, limit 1. Okay, so I have 3 different queries here, all separated by a semicolon. Okay, I'm going to just select it here to force it. If I could run this all at once, it executes them in one fell swoop. Okay. So in Table Plus, it puts the query results into different tabs. So if there are 41 products, in Query 2 tab it says hello, and in the Query 3 tab it shows the days to deliver for the first product. Okay. So this is what it means to chain SQL statements together. You can run them all at once. So because of this feature, you can do the same thing when you're typing in values into a form. So let's say we look at this form and we're looking at first name. Okay, we could type in SQL in here and possibly do something destructive to the database if they're not using prepared statements. So let's say on the back end, this is what their SQL statement looks like. And they're assigning that SQL statement to a variable called insert SQL. So say, okay, insert into users values just the first name. So let's say there's only a, and it's saying, okay, we're going to insert the first name and set it to Billy, but if somebody typed this into the form, because it's chaining it, it's going to insert into the users table with the Billy first name, but right after it inserts it, it's going to drop the table. Okay, so this is what it means. So if this first name field here is set to a variable, it's going to end up looking like this, where it's going to insert the value, but then also drop the table. Okay, so if you don't have a backup of that users table, this can be bad news for you. So this is why you want to use prepared statements to prevent SQL injection. Okay, because it's not going to be hard coding these values into the SQL statement. It's going to use a sort of a placeholder. As always, good practice, if you're ever accepting user input, whether it's through a web app or some sort of form or even an Excel file, always validate it to make sure that it is what you expect it to be. Okay, and even that to make sure the values match a certain format. Okay, so by validating it, you can save yourself from SQL injection attacks. So with prepared statements, you want to use them with placeholders. Okay, so if you were going to run that insert statement again, we can do insert into users values and then put a question mark as that placeholder. And then we can set a variable, and then it's going to interpolate or replace out that question mark placeholder with the variable name. Okay. But always validate your input. Because if you run this, if let's say Billy was, or first name was set to Billy, semicolon, drop tables, it will not work because you can't chain inside of this question mark. Okay. It'll throw an error saying invalid syntax. So that's one way of how it protects you from SQL injection. And then the last step of a prepared statement is a deallocate prepare. So this releases it from memory. So there are 3 steps to a prepared statement. First, you have to prepare it for execution. You have to say, okay, what is that SQL statement? So also in that preparation process, you're setting any sort of variables for those question mark placeholders. And then once it's prepared, you execute it. So then it runs on the database. And then once it's done running, you run a deallocate prepare. So it releases that statement from memory. And you want to release these statements because if, let's say, you have a high traffic site, if you don't deallocate, it's going to eat up your memory. And then if it runs out of memory, your database is going to run slower and then maybe have some memory leaks, or it'll start crashing and stop responding to your application. Here's the syntax again for prepared statement. In bold is what you're going to switch out. Okay, so you always have to name the prepared statement, specify the SQL with your question mark placeholders, set any variables that you may need. So you could use the set method or the select method. Execute it. Okay, so you execute it by calling the name and passing in any variables that you need to use for the placeholders, and then deallocate the statement with a deallocate prepare on the statement name. So for our next example, we're going to do the same thing we did in the previous example. We're going to insert a new product, but we're going to insert it with prepared statements. Okay, so this is the better practice to protect yourself against from SQL injection and also to make these inserts run faster. There are two parts to this example. We're going to insert into the products table, and then we're going to insert into the product vendors table. There's going to be a lot of code here, so I'm going to add some comments to make the code more readable. So I'm going to label this first portion as insert product, which will be the name of the prepared statement. Before we get into the prepared statement, we have to define our variables. So we're going to do the same thing. We're going to assign values for the product name, retail price, and quantity on hand with the set method, and then run a select statement to get the category ID. And then for the product vendors, to get those variables, we'll use a set for the wholesale price and days to deliver, and then run a select to get the product number using the last insert ID function, and then doing a select for the vendor ID. We can copy and paste from our example above, but we'll rename the values so that way we can differentiate from the products that we're selecting. I'm going to copy and paste the group of set statements and the select for the category ID. And then we'll rename this Linus Road Bike. We'll set it to, let's say, $250. And then the quantity on hand will be 40 units. The category ID select stays the same here. You have to make sure you run each of these statements. You can run them in bulk. Select and then run the current. Let's make sure the product name is now showing Linus Road Bike. Okay, good. And we'll double check for the retail price. And let's do and for the quantity on hand all at once, as well as for the category ID. Okay, good. We can start the prepared statement. I'll label this as step 1. We'll say prepare, and we'll name this insert product. Use the from keyword, and then close the SQL query, the insert SQL query in single quotes. Then we can actually copy and paste from above, but we have to make a slight modification to the SQL statement because we're not directly passing in the values with variables. We're going to use placeholders because it's with the placeholders is what makes a prepared statement secure. We're in that line, so it's prepared the statement, but it has not executed yet. That'll be the second step. Execute the name of the prepared statement, and we're passing in values to the prepared statement, which is why we use the using keyword, and we list in order of the variables that are taking the place of each placeholder. The first one is product name, and then retail price, followed by quantity on hand, and then finally category ID. Doesn't matter that the capitalization's off, but I'm just going to fix it for consistency. So at this point, the new product has been inserted. We can double check with a select statement. Select star from products where product name equals this variable. Or we could have typed in Linus Road Bike directly. Okay, good. So it was successfully inserted with product number 44. Even though it's successfully inserted, for good housekeeping, we should deallocate the statement to free up the memory. There you go. The product was inserted using this prepared statement, but we also have to insert into the product vendors table to keep data consistent. I'm going to call the second prepared statement insert product vendor. So I'll just put a label here. So when I'm reading through the code, it's easy to differentiate what are the different blocks of code, what's each block of code is doing. Defining variables again. We need to get the product number of this new bike that was just inserted. We're going to use the last insert ID function. And make sure to always use the select when you're calling this function instead of set. Otherwise it won't run. Colon equals last insert ID. I'll confirm 44 is what is inside of this variable. Good. Got the product number. Now we also need we're going to set the wholesale price and the days to deliver. Copy and paste it from the previous example. And I'll say the wholesale price is $125 with a shorter lead time of 5 days. Make sure to run it so it sets both of those variables. Then lastly, we have to get the vendor ID. We can copy and paste that code again. Here we go. Vendor ID 6. is now in the vendor ID variable. Got our variables defined so we could start preparing the statement. Step one. I said I'd call this statement insert product vendor. We can copy and paste the insert here and replace out the variables with the question mark placeholders. The question marks is what differentiates a prepared statement from just a regular SQL statement. Make sure to run the prepare. Now we're ready to execute the statement. We have to pass in the variables we're using to replace out the question mark placeholders. And again, they have to be in order. So the first column listed is product number. I'm going to use the variable last inserted product number, vendor ID, wholesale price, then days to deliver. Just double checking for any typos. Okay, good. Says it inserted. I'm just going to do a quick sanity check. Select star from product vendors. And we'll look based on the product number. Okay, good. It was inserted into the product vendors table. I just noticed I had a typo here, but it still works because user-defined variables are case insensitive, but I want to fix it just to be consistent. And then for the final step, we'll deallocate this prepared statement to free up the memory. Deallocate. Good. So there you have it. We've inserted a new product, and by inserting a product, we have to not only insert into the products table, but we have to also insert into the product vendors table. And here we use a prepared statement, and we're using user-defined variables to fill in these placeholders. All right, so make sure you save this file. You can do Control or Command S just to double check, or you can save SQL as again and then select the file that you use to download with your first name, last name, ending in a .sql extension. Okay. So if you wanted to insert a new product, you could pass on the SQL file to somebody, say, hey, these are all the different steps you have to use to insert a new product. And all they would have to do is just replace out the variables they need to insert that new product.